Okay, in this problem here, it says menthol is a member, that's menthol, let's write it down. That's a common name, right? Menthol is a member of the terpene family of natural products, and it exists like 1R, 2S, 5R, so these is 3 chiral centers, 1, 2, and 5. And it also exists as 1S, 2R, 5S. Let's see. The first question is, what is the relationship between these two? Then it asks you to draw each one of these, and then keep the most stable chair conformation. So let's do that. First step is, what are these related as? So carbon number 1 is R, carbon here is S. So one center is inverted. Carbon 2, here is S, now is R, inverted. Here 5 is R, here is S. So every chiral center is inverted, therefore these two are enantiomers. Now let's get to draw this with the absolute configuration. So my first step would be, let's name that IUPAC. So this is cyclopentanol, but it's got isopropyl in carbon 2, as we can see. This is isopropyl. So 2 isopropyl, then 5 methyl, cyclohexanol. All right, that's my termination for alcohol. Now I need to draw that. So the first thing I'm going to do is I'm going to do all of the chiral centers. I'm going to assign this randomly, all wedges, so that I have a hydrogen in the back and I do the configurations easy. And then we change what we need to change as needed. So everything wedges mean the hydrogen is, the lowest priority is in the back, in the dash. So now this is an OH. Let's do the configuration. This is carbon 1, 2, and that was 5. Now for carbon number 1, priority 1 is the oxygen. Remember, Cangical-Prelog rules. You go by atomic number of the atom that's attached or group. So 1, then I'm going to go 2 and 3. So this center is R. Now carbon number 2, this is your priority 1 is going to be to the right hand side because this carbon is attached to oxygen. Then your priority 2 is going to be this because this carbon is attached to carbon, carbon H. And that one is attached to a carbon and to 2 H's. So my priority 1 for the second chiral center, we're going to do 1, 2, and 3. So that's another R. Right, so I have RR. And let's do the final here. Priority 1, notice here that the H is in the back, so that's 4. The middle will be the 3, and here you have CH2, CH2, so same, but now travel 1 more. This side has higher priority, so I'm going to do 1, 2, and 3. Rotating clockwise, R. And I did it like that, everything in wedges, so that I have the hydrogens in the back. But this is not what I need. This is RRR. So if I want to draw this one, I'm going to change the configuration of one of these. So let's start drawing the molecule. So my goal now is to do this. So carbon number 1 says it's R, so I'm going to keep it this way. Same. Carbon number 2 says S. So if this is a wedge, I need to invert the configuration here. So that's 1. And next, the last carbon says 5 is R, so I can't keep that here. And so this is R, S, R, and this is 1, 2, 3, 4, 5, right? So this is this one. And obviously the enantiomer, how do I draw the enantiomer? I'm gonna change the configuration of each chiral center. So for carbon number 1, then I'm gonna have this on dash, and now this is gonna become S. I switch this to the wedge because again, these are enantiomers. So this is going to become R, carbon number 2. And this one, I'm going to switch to the dash. And so now it is S. So R is R, R is R, and the enantiomer is S, R, S. So enantiomers, these two. We have said that already, but now I have the pictures. Now, the next part of the, say, problem is drawing the most stable chair conformation for each of these. So now I'm going to erase this because I need this part to draw the chairs. So now, and I'm going to erase that too, now that I have my two enantiomers. Let's work on the first enantiomer, this one here. So when you're drawing your chairs, first I'm going to draw that chair. And I want you to do the following. I mean, it's easy. This oxygen is pointing up. The isopropyl is pointing down relative to this plane. So it's either going towards you or against you. So I'm going to say up, down, and this is up. So I'm going to replicate that here. And so I'm going to say oxygen up. So I'm going to pick this as carbon number 1. I'm going to kind of put the oxygen in equatorial, but it's pointing up. Right? So if this is carbon 1, then carbon 2 has the isopropyl pointing down. So in that chair, let's do just the positions. Label axial, equatorial here. The axial, remember, are vertical lines. And these are axial positions. And they go up, down, up, down, up, down. And the equatorials go, you need to keep this angle 109 approx. So that's why this is slightly down, slightly up, down, up, down, up. These are the equatorials. Now, keeping that in mind, this we said it was up. Now, the isopropyl is in carbon 2. I'm going to say that. And it's pointing down. So I'm going to put my isopropyl right here. And then if this is 1, 2, 3, 4, and 5 is here. And now what I see here, metal is up in carbon 5. So in carbon 5, that metal, see, this is up, pointing up, is that way. It's actually the most stable conformation. Everything is in equatorial. If I had chosen to draw something else, let me choose another drawing. So this is the answer. Because everything is equatorial. All the trees to citrus. Say that you have done another drawing. If you had done here up, carbon 1, and down, the isopropyl, but this is diaxial. And then 1, 2, 3, 4, 5, and 6. And 5 is up. So this is everything in axial. So that's very high energy. So this is why this is your answer. It's still, this is up, down, up. Same, all right? But that's your most stable chair. So now let's do that. Again, I'm going to start putting the OH here. And I'm making it equatorial because I want to put them, most constituents in equatorial if I can. So that is the enantiomer. And because I want this in equatorial, so now I'm going to say this is carbon number 1 because, see here, axial in equatorial. So I'm going to name this carbon 1 and I'm going to put my OH there. And then this is carbon 2. This is down, so let's do this. Down, up. So the isopropyl is up. So it's going to be like that. And then if this is 1, 2, 3, 4, and 5, this is pointing down. Yep. So down at that position is here, which is equatorial. So that's also your answer. Everything is equatorial. So, and if you analyze this cutout center, this is that. It is inverted. And we can check that with all the chairs. But again, that's your most stable chair because every constituent is in equatorial. So that's how you solve that problem. Again, what did we do? We had menthol, and menthol didn't have any configuration. I did an initial drawing with everything on wedges so that it was easy to assign the absolute configurations. That's menthol, which is 2-isopropyl 5-methyl cyclohexane. From here, I went, this is R, this is R, but this is S actually. And so from here, you go here. That's what we're doing. All right, this is it.